Distributions and outliers. So an outlier is a value in a data set that is much greater or much less than most of the other values in a data set, because not everything goes as expected, right? Things could be really typical, but then one day something can be very different. So those are what we call outliers. It's important to be able to identify those like in the real world, because maybe we'll want to exclude them from our data set because they don't accurately represent the whole population of whatever it is you're serving. So there is a way you can kind of just assume something's an outlier visually, but the one way to know for sure is to use this formula. It's a data value x is an outlier if x is less than q1 minus 1.5 times the IQR, or if x is greater than q3 plus 1.5 times the IQR. I will be nice and provide you those formulas. They will be right here during the test, but I will not tell you which one to use, because as you can see, there's two formulas. You have to determine which one is the appropriate one. So you use the one that's on the left. One second, let me get my pen to wake up. All right, you use the one that is on the left when the data value that you are testing to see if it's an outlier is much smaller than the rest of the data. You use the other one if the data value that you're testing is much larger than the rest of the data. So that's how you'll know what equation to use. I will not tell you which one to use on the test. So here's the first example. We have a data set of some salaries at a small company, and it's in thousands of dollars. Okay. It's in thousands of dollars. So here's what they make. Now suppose that we expand the list of salaries to include the owner's salary of $150,000. So now we have the data set from before and 150. Without doing any math, which one do you think is going to be the outlier? The 150, because it's an extreme value. It's much larger than the rest of the data. However, sometimes they ask you values that are closer to the data, which is harder to tell. All right, I'm going to skip the dot plot for now. All right, hopefully you guys know how to make dot plots. First, make sure that you have an appropriate scale. So since the numbers go from like 25 to 150, you want to have it include all those numbers. And then for each data point, you're putting a dot or an X over each data point. So like 25, 20, and so on. Right, and if there's 235, like there is here, you stack them on top of each other and so on. I might as well finish it, but I think you guys see the point. All right, so even just visually, you can see since that one is farther from the rest of the data, that one is probably the outlier. But to mathematically prove it, you can use that formula that we mentioned before, because it will be trickier on your test. So in order to use that formula, I need to identify a few things. Also notice they're choosing this formula instead of the other one. Why? Because the 150 is much larger. So you use the formula for the numbers that would be much larger. So that formula, you plug in the data point that you are testing, which is the 150 for the X, like they do here. And it's greater than Q3, so I need to identify my Q3. And I need to identify my IQR. What's the formula for IQR? Q3 minus Q1. So I need to identify Q3 and Q1. Before I do that, what do I need to identify first? The median. So good. We need to list all of these values in order from least to greatest. I'll use my dot plot for that. Just let me know if I miss any, because I do sometimes. 20, 25, 35, 35, 40, 40. Just 150, a 60, and a 150. If I started out with 11, I should have 11 in my list, which I do. So from least to greatest is what your numbers need to be in before you identify your median. All right, so then identify your median. Go left, right, until you get that middle number or middle two numbers. Since we have an odd number of data points, it should just be one number in the middle. And what is my median? 40. So remember, that's my Q2. That's not needed for the formula, but you need it to split your data to like your lower half and your upper half. So then find your Q1 and Q3. So never cross out your median. My Q1 is 35. What's my Q3? 50. Good. Any questions on how we identified those values? All right, so then you plug them into the correct formula. So the correct formula is the one that's here for the bigger numbers. So 150 greater than Q3, we said is 50 plus 1.5 times the IQR. So if the IQR is Q3 minus Q1, what's 50 minus 35? 15. All right, once you've done that, what is to the right of your symbol, you can put in your calculator. Just make sure that you don't miss any parentheses or anything like that. That will change your answer. All right, so you put that in your calculator, just the right side of your inequality symbol. And this is what we get, 72.5. So it says 150 greater than 72.5. So does that mean the 150 is an outlier?
Yes.
Yes, because what we got was a true statement. So that means it is an outlier. All right, really anything that's greater than 72.5 is an outlier. So would 100 be an outlier?
Yes.
Would 73 be an outlier?
Yes.
Would 72.5 be an outlier?
No.
No, because it's 72.5 greater than 72.5?
No.
Exactly. So it has to be greater than 72.5 to be an outlier. So what if the number was 60? Would it be an outlier?
No. No.
No, because it's not greater than. Make sense? So go to the backside real quick. This, if you want a copy from Schoology for time's sake, you can. But all this says is like, let's say the owner's salary is adjusted to be 65,000. So now instead of the 150, it's a 65 for the maximum value. Does that change my Q1, Q2, or Q3? No, it doesn't change either of those because all we changed was the maximum value. There's still 11 data points. Normally, like if you take out a value, you'll have to like reorder the numbers and find your new median and find your new Q1 and Q3. But you don't have to because you just changed the maximum. But if we're testing to see if 65 is an outlier, we already should know from the page before, is 65 greater than 72.5? No, so it's not an outlier. Make sense? All right, scrolling down real quick. Let's look at one where it's testing a value that's smaller, so we're using a different formula. So like this baseball example. First thing you should do with the data points, because this one just says determine whether the extreme value is an outlier, so it doesn't specify. First thing I should do is what? Put it in numerical order. So that's what I'm gonna take a moment and do right now. You guys wanna help me out? Make sure I don't miss any points, because I did earlier. All right, should I have 11? Let me see. All right, great. So it doesn't say which one's the extreme value. Which one do you think it is? Do you think it's the 72 or the 100? Well, this one is 8 away from the next data point, and this one is 7 away. So slightly a little bit more, the 72 might be the one that's the extreme value. What equation do I use to test for the 72? Good, you'll use this equation, because this time the data is much smaller, or the one that we're testing is much smaller than the rest of the data. All right, I know we're pretty much out of time, so I'm just going to show you the answer now. All right, but that one would normally be your turn. Have you tried it? Find your Q1, Q2, Q3, and then plug it in. Q1 is 81, IQR is 9, 72 smaller than 67.5. So is it or is it not an outlier? Not an outlier.